All right, let's get started. Hi, everyone. I'm Jinhua Zhao, Professor of Cities and Transportation at MIT. This is the MIT Mobility Forum organized by the MIT Mobility Initiative. Today is really my great pleasure to have Professor Jason Tao join us talk about the machine learning application in land use and travel behavior analysis. As we know, land use and travel behavior relationship is one of the core questions that city planners, transportation planners focus on. And when we apply models, the typical process it requires a priori assumption. And given that assumption, we collect data and run models. Right? So Professor Tao today will actually try to look at how machine learning as a tool can help us solve many of the problems that previously very difficult to resolve. For example, are we looking at the different type of relationship that a prior assumption may not be correct, right? Can we discover interactive effects among many variables that we didn't beforehand actually specify in the equation section, right? So that we'll really look forward to this discussion today. And let me reinforce the norm of this forum again, which is everyone contributes one idea, right? While you're listening to Professor Tao's talk, please write into the chat either a comment to the presentation or a question to Professor Tao on this. Right? So here, let me formally introduce Professor Jason Tao. He's a professor at the University of Minnesota at Twin City. He specializes in the land use and transportation interaction, as well as the effect of ICT on travel behavior and planning for the quality of life. He's internationally well known for his research on residential self-selection in the relationship between building environment and travel behavior. His recent work brought in the machine learning tool to address the nonlinear relationship in the land use and transportation research. He's the co-editor-in-chief of Transportation Research Part D, a leading journal in the transportation research, and also associate editor of Transport Policy. Another role Jason plays is he was the chair of the International Association for China Planning, and also more generally, which I'm really grateful for Jason to do, is promoting the urban planning scholarship in China by collaborating with the Chinese scholars, unifying the Chinese student scholars, and bridging the Chinese and the international scholarship. I emphasize because at today's difficult geopolitical situation, I really appreciate that Jason continued to bringing the different parties together and really try to construct a coherent scholarship community in urban planning and transportation planning on this, right? So without further ado, let me pass the forum to Professor Jason Tao. Jason, please.
Okay, thank you very much, Jinhua, for your nice introduction and invitation. And now I'm going to share my screen. Just give me a minute. Can you see it okay?
Yeah, it's still the, oh yeah, no, it's great, yeah.
Okay, nice. That's great. And as Jinhua said, during the past several years, I have been working on using the machine learning, trying to understand the connection between the land use and travel behavior. So today's talk is really just kind of my reflection of my previous work. And also I want to see how the machine learning application can improve our understanding between the connections between variables. So, when we do the land use and travel behavior research, we need to use the models. So in that case, I'm going to borrow the idea from the UC Berkeley professor Leo Bremen's paper, Two Cultures of Modeling. So what he argued is, think about our data. Actually, data are generated from kind of a black box because we don't really know how it was generated, and then it's very complicated process. But as scientists, we are trying to open this black box. And then there are commonly two approaches to address this issue. One is called data modeling. So in this case, we assume the data are generated through a causal pathway with a known distribution. And because of this distribution, and then we choose the model to understand the connections between variables. For example, if we assume the data follow the linear, normal distribution, and then we will use a linear regression. If it is a Poisson distribution, and then we may want to use the Poisson family regression. But the issue here is if the data do not follow the assumed distribution, and then it may produce irrelevant theory and questionable scientific conclusions. And then the other approach is, we are trying to use different algorithms to test and to see, which function will produce the best result. And then we will use that model and to show the finding. So in this case, the machine learning is one type of this algorithm modeling. From my perspective, I think the main difference between this approach is the data modeling is, thinking about how the data will fit a model. And then when we think about the machine learning, we are trying to use data to predict a model. And actually, through my previous research, I have found out the machine learning can address at least, provide 3 insights into our understanding about the connection between the land use and travel behavior. So now I'm going to focus on the first one is, the machine learning can correct the questionable conclusion from data modeling. So this case study is trying to understand the connection between the distance to centers and also the driving distance. The motivation is, thinking about our metropolitan area is moving from the monocentric to polycentric urban form. And then we have the city center, regional center, and local center. And as urban planner, we try to understand, how the different centers play a role in terms of people's travel behavior. And then what should we do? So in general, we will just measure the distance from my home to city center and to regional center and also to local center. I put this 3 distance variable in my model of the travel behavior, say the driving distance. And then I will see, which variable is significant in the model. But if we look at the literature, we find out in general, the city center, this variable, is significant, but the regional center and the local center, they are not significant. So the implication is, the distance to city center play a role, but the distance to regional center and to local center, they do not play a role in my behavior. But I don't think this makes sense because, I try to understand how the centers will influence my travel behavior, actually influence my activity location choice. And then based on my colleague, Peter Nice, the argument, actually, he said people choose their location based on either the best facility or the proximity. For example, if we are looking for a specialized goods, so in this case, more likely, we are going to find the stores in the city center because there, we see very high accessibility. So in that case, we will go the best facility in the city center. But if we buy some non-specialized goods, for example, we just buy some grocery, we just go to our local shopping area. So in this case, the proximity will play a role. But, based on the theory, it seems, both the city center and then the local center will play a role in my activity location choice and also my travel behavior. But turns out the model does not tell us, this kind of results. And then the second inquiry is regarding this kind of the linear connection, because very often we will use a linear model. So in that case, we will assume the distance to city center will have a linear connection with my driving behavior. But the issue here is, think about we have only 24 hours, and then we will allocate maybe 60 minutes or 90 minutes for our travel. So in that case, if I live further away from the city center, and then my daily life, is not going to centered on the oriented towards the city center. I'm thinking about my local center or regional center. So that means thinking about the distance to city center after a certain threshold, we may see the influence of distance to city center may decrease or saturate, right? So in that case, because of these 2 issues, I'm trying to answer this question: how important are the effects of the subcenters relative to the city center on driving distance? And then the second one is, do they have the nonlinear relationship? So in this case, we use the data from Oslo and Norway, and the left figure is kind of the map of the country. And then if you see the yellow part is the country of Norway, and then the Oslo is on the lower part is in the Bay Area. And then on the right-hand part, so this shows just the Bay Area, the Oslo. And then because of the Bay, you can see, the Oslo is more of kind of a monocentric city, but apparently we also see some local centers and regional centers around. And actually the right one is the employment density of Oslo Bay Area. And then for this particular study, our dependent variable is the weekly driving distance. And the building environmental variables include the distance to the main centers, regional center, and then the local center. And also we measure the population density and job density, and also whether or not this area is served by the transit. And then we use the GBDT in the R package to do the analysis. Now I'm going to show you the result. This one shows, the feature importance of different variables. So in this model, you can see I include two big categories. One is demographics, and then the second one is the building environment attributes. And then we can see, on the last column, it shows the importance of the variable. This one is different from the p-value. Here, the relative importance mirrors the contribution of this variable to the reduction in error compared to other variables in the model. If we add all the relative importance together, that's going to be 100%. And then if we look at the result, so we can see the distance to city center, this single variable accounts for 18% of the predicted power. Think about 100%, this variable is 18%. So this is the most important variable. It makes sense because the Oslo is most of the jobs are around the city center, and then if you live further away from the city center, you tend to have longer driving distance. And actually, this one is the weekly driving distance. If we just focus on the weekday driving distance, this variable, the relative importance is 24%. And now let's look at the distance to the second order center and also the local center. They are not that important compared as the distance to city center, but actually 10% is still a very sizable influence on the drivable distance. Next, I'm going to show you the partial dependence plots. So this one shows kind of the marginal effects of the distance to city center on the expected driving distance. So horizontal is the distance to city center and vertical is expected driving distance. So we can see they have a positive connection. That makes sense, right? When you live further away from the city center, you tend to have a longer driving distance. But within 12 kilometers of the city center, we can see the slope is smaller. But after 12 kilometers from the city center, we see a jump in terms of the driving distance, right? So that means clearly we see a nonlinear and also the threshold influence of distance to the center on driving distance. And now let's look at the distance to the second order center. That's the bottom figure. So we can see, similar trends. They have the positive connection, but within 8 kilometers from the regional center, the second order center, we see the slope is pretty flat. And then if you look at the right figure, that one is the distance to local center. This one is within 4 kilometers from the city center. We see a smaller slope compared to the rest of the distance. So based on these results, we can see, first, the city center is really important for our driving distance. But the second order center and local center, they are also important. If we add their relative importance together, it's kind of comparable to the city center. So the question is, why does machine learning produce these different results? Because I have tried using the regression analysis, and then I found out only city center is significant, and regional center and then the local center, they all play a role. And then my guess is why is because of the nonlinear connection. From the previous slides, we can see the distance to city centers have a clear nonlinear connection with the variables. If we don't consider this, apparently we are going to misestimate other variables, right? And also maybe because the distance to city center, distance to second order center, and also the distance to local center, they have some kind of the multicollinearity issue. And then they force the second order center and local center became insignificant. And also from this case study, we also have 2 additional notes I want to make. One is, if you see the previous slides, they show the nonlinear connection, but also the pattern of the nonlinear relationship vary by variable. So actually the machine learning is a more efficient tool to estimate this irregular nonlinear connections because, we don't have any prior information, right? So it's more efficient. A second one is, we have seen this kind of the threshold, the 12 kilometers, 8 kilometers, 4 kilometers. That's going to provide some planning guideline. For example, if the Oslo think about how to reduce the driving distance, reduce carbon emission, actually they can direct the future residential development in the area within 12 kilometers from the city center, 8 kilometers from the second order center, and 4 kilometers from the local center. So in that case, we are going to have a smaller driving distance and then the fewer emissions. So this is the first case study. Actually, you can see the machine learning correct this questionable conclusion. if I use the linear model, the result is only one is significant, but actually all three are very important. And then the second case study is to show, maybe we have variable is very important and also the connection makes sense, but actually this is not really a feasible building environment intervention. So for this case study, we are using the data in the Twin City area. So using the regional household travel survey in the Twin Cities. And then if you see this, so on the left-hand side, so this is the map of the 7 county area of the Twin Cities. When we say the Twin Cities, we have Minneapolis is the business center and St. Paul is the political center. That's the orange, these 2 central cities. And then if you see the pink area, this is kind of the beauty area of the 7 county area. And then if you look at the red map, this one shows the population density in the region. So apparently you can see the density is pretty high in the 2 central cities. But in the suburban area, you can see there is a density gradient, right? And then for this question, for this case study, we are trying to understand the connection between the building environment and then the car ownership. We measure the car ownership as the number of vehicles per licensed household member in the household. And then the independent variables include demographics and then the different dimensions of the building environment. So particularly, we have the population density and then the diversity design, blah, 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 right? And then in terms of the methods, first I use a linear regression and then I tested the model. I found out actually the population density, this variable is significant. So that means it has an effect on the car ownership. And also it is negative. So the implication will be, okay, if we don't think about the causality, okay, the implication is as long as we increase the density, we are able to reduce the car ownership, right? But then, we tested using the gradient boosting decision tree, this machine learning approach. So here, I'm going to show you the result. First, still, I want to show the relative importance. From here, we can see the relative importance variable is 99.4%, almost 10%. And actually, this is the second most important building environment predictor. Okay, among the building environment variables, this is the second most important. And then you can see the left figure. This one shows the ALE plot. So this one is really similar to the partial dependence plots, but this is the unbiased version of the PDP. So here, the horizontal is the population density, and the vertical is kind of the expected car ownership. So we see, first, about 10%. So this is really important. And also, if we see the connection, this is a negative relationship. It makes sense, right? And then for me, I really want to know, okay, where the drop occurs. And then first, we can see, when the population density is smaller than 3% per acre, we can see a drop in terms of the car ownership. And then where it is, actually, this is the rural area in the Twin City. So can we increase the density in the rural area? Probably not, because we see the urbanization, right? The people, is going to move to the cities, to towns, instead of moving back to the rural area. So that means increasing the population density in the rural area can be difficult. And then from the 3% per acre to about 18% per acre, we don't see much variation in terms of the population density. But after, in terms of the car ownership, but after the 18% per acre, and then we see a drop in car ownership. And then what does the 18% per acre mean? So think about the Twin Cities. So the Minneapolis is the densest city in this region. Actually, the average density of the Minneapolis is 11.5% per acre. So that means if we want to achieve the car ownership reduction, we may have to increase the average density of Minneapolis by more than 50%. And then I want to know where those census block groups located. And then I show the red figure. So you can see this blue area. This is the 2 central city, and then Minneapolis and St. Paul. So you can see, the vast majority of the CBG with population density more than 18% per acre are within the 2 central cities. And then the vast majority is surrounded the downtown Minneapolis. That's the economic center, right? That makes sense, right? And then, but can we build a metropolitan area just all like the south, surrounding the Minneapolis? I don't think that makes sense, right? And I also think about this is 18% per acre is really just the starting points of the decline in car ownership. if we want to achieve the full potential, we need to reach 28 persons per acre. If we draw 28 persons per acre, only a few spots in the city, we can see this level of the density. So that means you can see, yeah, this variable is particularly very important and also makes sense. But when we look at this ARE plot, actually, there's not much the urban planners can do, because for the urban planners, we can try to improve the population density is really in the middle part. And actually, along this middle part, we don't see much variation in car ownership. And the third case study is, sometimes, we don't really know what's going on with the data, right? So in that case, the machine learning can be an effective way to identify some interaction effects. And then now I'm going to use a case study from colleagues in China. And then what they did is, they try to understand the connection between built environment variables and the cyclone distance. So they use data from Xi'an, China. And then the key dependent variable, they include built environment attributes, and also they have the average geodesic distance. And then for this variable, a smaller value represents more direct connections, okay? And also with the between its centrality. So this is a smaller value means more accessible and interconnected network, right? And then they use the method is called XGBoost, and then the sharp value to analyze the data. So here, I'm going to show you the results. So this is also, kind of a PDB plot, but this is really based on the sharp value. Okay, if we do look at the color of this map, the axis is the average geodesic distance, and then the vertical is kind of the cyclone distance. If we don't look at the color, we have the sense is, these two variables have kind of the positive connection, right? So one bigger, the other one is bigger. But if we separate, look at the color, if the between its centrality is small, so that's really the blue dots. So we can see, they have kind of no influence, and then we see a negative influence after, it exceeds maybe 2.5 and 2.4. Okay, in this area, you can see they have a negative relationship. And then if we look at the medium level of the centrality, so this is represented by the purple points, more likely to be kind of V-shaped. And then if we look at the right one, this is the large centrality, we can see this is really kind of the positive connection. So from here, because we don't know, we don't have any knowledge regarding, their interaction effects. But based on this PDP, clearly, they show some, the influence of the distance on cyclone distance, is moderated by the between its centrality. So based on this study, we can see, the first case study, challenged the conventional understanding of the connection between the distance to city center and then distance to centers and the driving distance. So actually, this one, fulfill the goal of, correcting the questionable conclusion based on this unreal assumptions, right? So we assume they have the linear relationship, but actually it is not. And then the second case study, the third case study, it shows actually, the machine learning improve our understanding of the connection, okay? Because, because we don't have any prior knowledge, and then now because of machine learning, we can see the potential interaction of variables on the cyclone distance. And then the third one is, this case study inform the planning practice, let the planners know, actually, yes, we do see a variable is important and it's plausible, but actually it is not feasible, we cannot do much about it. So based on this case study, I hope, the scholars can embrace the urban machine learning. So in that case, maybe we can, try to bring some new insights into this literature. That's my presentation. Thank you.
Right. Thank you, Jason. It's really interesting. Both the three cases illustrate the three contributions that machine learning can have, but also they come from three very different geographic setting there, right? From Oslo, from Twin City, from China. A really nice combination there. So maybe I'll start with the question about this. The relationship may be important and meaningful, but not actionable here. right? So at the beginning, when I just look at the abstract and misunderstood, I thought it's the machine learning identify this. But here you're saying if this variable has a piecewise relationship with the dependent variable we care about, right? Driving distance, ownership, etc. But if as a planning, we can only operate in a certain band, but during this band, the relationship is very flat, then whatever other relationship is not meaningful here, right? That now I see your interpretation here. So for that, let me tell us a bit more about this, right? So it seems that in the prior literature, we may reach a lot of conclusions like that. We increase the density, we increase diversity, therefore lead to certain expected outcomes. So given this challenge, do you suspect that we should revisit many of our prior literatures? That we may have made several similar mistakes here. Is that useful here?
Yeah, I fully agree. And actually thinking about, if we have we have 3 case studies, and all 3 studies using the regional travel survey, say one using the Minneapolis, the other one using Boston, and the third one using the Los Angeles. And then we make the same linear assumption, and then we come up with the conclusion. All, for example, the population density and counter shape, all of them are negative. So based on these results, our impression is, the results are consistent. So that means they are correct. So that means, yeah, as long as we increase the population density, we could reduce the car ownership. But actually, maybe all 3 studies made the same mistake because of this unreal assumption. So actually, if we relax this nonlinear, this linear assumption, we may reach entirely different results, just like what I did, for the Twin City area. So maybe all 3 metropolitan area, you may see the similar pattern. So in that case, that's going to challenge our current understanding. So that's something because, it's really the assumption. And also I'm thinking about, as a researcher, when I use a model and then I come up with the result, I publish the paper, how often, I check the distribution of my dependent variable. Whether or not that's really the normal distribution, that's really the Poisson, or that's really the logistic, right? So that's, something, as a researcher, we need to think about. And also think about when I was a student, at UC Davis. And then my professor in statistics, he told us, if you don't check the assumptions associated with the models, some fundamental assumptions associated with the models, actually, he said is the garbage in, garbage out, because, the result is kind of misleading.
Yeah. So actually, that relates to another point about in planning and also in interpretation as well. We often do not have this standardized database. Therefore, when someone publishes a paper, it's very hard for another scholar to replicate, right? Unless you have very special opportunity. So on that, there are several scholars try to call for a standardization and open sourcing of this data set, right? Just like in computer science community, we have many of these standardized procedures, standardized data set. Whenever you develop a new methodology, you check against the 10 standardized data set. You don't even need to explain. Everybody knows what it is. So here, how do you see in planning field to form this tradition so that we can collectively improve the community?
I would say, for example, I'm using the regional household travel survey, right? And then I assume the Boston and Chicago, Los Angeles, maybe, even in China, right? Chinese cities, they do have this kind of data. So this kind of data, they tend to follow a certain format, right? So in terms of the variables they collected and then the sampling procedure and the variables they measured. And then, so I think, we see a very good, the analysis using this kind of data kind of comparable. And also, in the United States, we have the National Household Transparency Survey, and also we have certain metropolitan areas, they have the add-on data, right? So in this case, if we run, for the individual metropolitan area, we run kind of the same model, and then we can try to compare the results. So in that case, that will provide about the generalizability of the results. And also, I think Professor Reid Ewing has and his team has done something, using the data from several metropolitan areas, trying to understand this kind of mixed development and then how that mixed development is going to influence behavior. So that's kind of one way of thinking about this issue. And also, I know some researchers, they do, for example, research in terms of the attitudes and behavior, and then they are trying to do some kind of meta-analysis and then come up with a list of the attitudinal variables, and then encourage other researchers when they collect data using this kind of standardized measurements. So in that case, the result can be comparable.
Thank you. Another question about the first case study there, right? I noticed that before you run the machine learning model, you already had at least a hypothesis saying that the best facility will lead to the connection to the downtown, the city center. While if it's a common good, I may just go to a local store, so proximity matter. So what it means is even before you use machine learning, you already has some sense of there's something going on here on this, right? So that point to a general question about this knowledge production process. This is really two very different norms, right? One is saying I have a theory, either a formal theory in the literature, or I have a weak theory based on my hypothesis or experience, right? Versus this machine learning approach that I don't need to have any hypothesis to start with. I just drop in the data, show whatever pattern there, right? Yeah. So I feel like in case study one, you already bring the two together almost, even though you are using the data-driven approach at the operational level, but you did have some theory to guide you towards it.
Yeah, that's exactly right. Actually, I have thought about this question for years, because, I try to understand which one is more important in terms of the distance to city center, distance to local center, right? And then, I use the traditional tools, but I cannot address them. And at that point, I thought about maybe because of the multicollinearity, because distance to city center and distance to regional center, they tend to highly correlate with each other. But I don't really have a good tool to address that. And also, I know they have certain kind of nonlinearity based on, say, either the time geography or maybe the travel time budget, right? So whatever. So, we see their potential nonlinear connection, but I don't really know where is the threshold because I have no knowledge. And then I have no knowledge about Oslo, right? Because I live in the United States. And then, so I struggle with this issue for a very long time. I don't really know how to address that. And then I had an opportunity to have a dinner with a professor from Beihang University, Professor Chuan Ding, and he's the first author of that paper. And then, I explained to him the situation. I struggled with this for years. And then I just feel so frustrated because I think I have done a lot of research in this area, and then I'm pretty good in terms of the data analysis, but turns out I cannot address this issue. And then he told me, okay, we do have another tool, maybe we can try it. Okay, so that means for this particular research, it's really, I have the hypothesis, I have the theory, and then I find the right tool to address it. And then I find this result. I was so excited, right? And then after I realized this is an issue, and then I start to use this machine learning approach to think about other data and then other theory and to examine other theory. So that means this is, for this particular study is really, okay, theory driven. But for my second study, for the Twin City area, I would say this is more the data driven. When I see the results, I was so frustrated because I see the result is so common to, everything makes sense, right? So I don't feel excited. And then I just think, okay, what can I get from this analysis? I find out actually, if I see the density, this variable is important, plausible, but actually, is in the area the planners can change the population density. We don't see much change in car ownership. And then they become the motivation of my research. So that means you can see these two examples. One is the theory driven, and then the second one is more the data driven. And then I try to use my knowledge in the planning and also in the theory to inform, this model. Okay, how this model will produce something significant.
Right. So maybe the last two questions from me. I don't give John for the audience question. The first one is any downside or danger of using machine learning or misuse machine learning. The fact that now I have this powerful tool, I can just collect whatever data, dump into it, find whatever pattern, plot it out, right? Yeah. So what caution you will give the audience about using this tool?
Okay, so I think this is a very good question. This is related to your previous comments. I would encourage particularly young scholars. Young scholars, they have a very deep learning curve. They have the data, and then they can they understand how to use this tool very efficiently, and then they just plug in the data and then come up with the results. And they don't even think about the theory or maybe the story behind of their data analysis, right? So that means they are just doing kind of one exercise. Okay, you are as a data analyst instead of as a transportation or urban planner. So I think my encouragement is, okay, so when you do the data, before you do the data, and think about the theoretical foundation for your work. Okay, so in that case, use that theory to guide your data analysis and also guide your interpretation of the results. So in that case, you are not likely to make a significant mistake, right? So theory driven. And also this is kind of an issue, think about it in, I'm also editor, right? So, I do see a lot of papers using the machine learning, trying to understand the connection of the nonlinearity threshold relationship. And then my question is, so what, right? So that's, why it matters. I know if you use the machine learning, you have to get nonlinear results. You are going to have the threshold connection. And then what does that mean for the policy making? What does that mean for the planning practice? So how that consistent with theory or the challenge theory. It's okay to challenge the theory, right? But you need to have kind of some arguments why this is the case. It's a kind of persuasive, right? So I would say, this is first is about theory driven. A second one is, I would say, very often you may see some different results, and then you really need to work on those results. Okay, is this kind of the by coincidence, or this is really, just it makes sense, right? So in that case, if you have some kind of theory or some foundation to support that, instead of just saying, we find this bizarre relationship, and then I would say, that's pretty ad hoc. And also, think about modeling, right? So even we do the data modeling, you want to come up with results, it's pretty simple. A couple of weeks, you can do that. But if you want to be a good modeler, it's going to take you maybe 2 or 3 years. It's kind of the same thing for the machine learning. Okay, you come out with the results, it's pretty simple. But if you want to make sure you do it right, so that's going to take time, and also, for you to learn, and then also to accumulate knowledge, and then you can produce the better results.
Great, thank you. A last question from me is, I'd like to get your view on the future research direction in this built environment and travel behavior relationship field, right? We've been working on this field for decades there, right? So for the younger generation, say, where do you see as the potential gap that if I'm a young PhD, Professor Gao, give me some guidelines of where do you think as more fruitful area to explore here, right? Compared to, say, in the 90s or early 2000s, because we have better data, better sensing, or because we have better analytical tools, or we have a different policy relevance in this, right? So give us a thought on the general area where excites you in this field.
Think about this area, the land use and travel behavior. It started in late 1980s, maybe the beginning of the 1990s. So that means close to 40 years, right? So how many papers in the field? Maybe thousands of papers, right? So that means you need to find a niche in this particular area is pretty challenging. And also, I think, because I'm doing research on the machine learning, trying to understand this nonlinear connection, so I would advocate for this direction. Is really, as you said, the first question. Okay, so maybe we should revisit our understanding between the connection between the built environment and travel behavior, right? So in that case, if we relax that assumption, okay, are we going to have kind of similar results as before? Okay, maybe that's going to fundamentally change our understanding. Maybe our previous knowledge, many of them, they're just wrong, right? So there's opportunity. And also because we have a lot of data, right? So previously, we just use the traditional survey, but now we do have, say, the mobile phone data or some big data, right? So with that big data, and then with also, this kind of curiosity, and then with the tools, we can have a better understanding of the connection between the built environment and travel behavior. I would say the most important thing is, whether or not with the new tools, with the new data, the previous understanding still stands or not. Okay, if not, and then how do we make the adjustment? So in that case, can inform our understanding. More importantly, inform our planners. So in that case, they can make the efficient and effective decision, because the built environment, once built, is going to stay there for decades, right? So it's not easy to change. So that means it's particularly for the developing country, don't make the mistake, right? So in that case, maybe make fewer mistakes. So that means we can have a more sustainable transportation. So that's the reason I would say, particularly for the younger generation, you need to embrace the machine learning and then the AI. And also, I know in the field, transportation planning, we do see a group of researchers, they are using the AI to make the demand forecasting, right? So previously, we used the traditional 4-step modeling, and then we moved to the active-based modeling. But now they are using the machine learning, using the AI, and trying to do the prediction. And then if turns out it's most, if they are successful, and then that's going to fundamentally change, our game, and also change our decision making.
Great. Yeah. Let me jump to the spotlight for the questions from the audience. John.
Thank you so much, Professor. We had so many comments and questions in the chat. Most of them were of a kind of methodological nature, so I will turn to those in due course. But maybe just before that, I want to ask what you could say is maybe a little bit of an unfair question. So I'm just giving you a warning. I want to build on Jinhua's questions about what is actionable from this work. And so I wonder, we have, let's see, 168 people on this call. If you were to imagine that those 168 people were mayors or city planning leads from cities around the world, what advice would you have for them based on your years of research? What suggestions or what policy recommendations do you see have emerged from your research on this very important topic? And again, I know that this is trying to simplify and that cities are very different from each other. So again, this is a bit of an unfair question, but I'm just curious, is there anything that, as you reflect on your career, that has risen to the top that, people just don't get this and they should understand this better? What message would you have? What recommendations would you have?
Okay, I would say, I will base on still the results of my research and also building upon the machine learning. Thinking about the first case study, at the end of that paper, I talk about the policy implication of that funding. So it's really think about the Oslo, in 2017, they plan to the 25% increase in population, but they want to maintain the 0 increase in carbon emission. How to achieve this? It's challenging, right? So that means, yes, we can have the electric vehicles, but also the urban planning can play a role. So based on that analysis, we say, okay, for the future population growth, they should occur within 12 kilometers of the city center, 8 kilometers of the second order center, and 4 kilometers of the local center. So that means this is an evidence-based approach, right? Okay, let the mayor know, okay, if you do this, yes, we still see maybe they still will drive, but they live further away from the center. But the increase is not that great compared to if they live in the kind of distant suburban area, right? So this is one implication. And also, I had another study with my former doctoral students, Dr. Tao Tao. We use the data in the Twin Cities. We try to understand, okay, we have the urban and suburban, right? And then in that study, we found out actually many policies, they work very well in the urban area, but in the suburban area, sorry, they don't work. So for example, think about the population density and land use mix. If we increase the population density, if we increase the land use mix, the people are going to have a shorter driving distance. But when we think about the suburban situation, sorry, those two variables, they just flight, okay? They just flight. So that means because, when we use the machine learning, and then we can see the full spectrum of their impacts, and then we can tell, our policymaker and also the planning directors, okay, which policy may play a role in our future if we want to manage people's travel behavior, which variable will play a role. So you can see, it's really evidence-based, but this evidence is really based on this machine learning, just provide this kind of new insights. If we use the conventional models, sorry, we couldn't find this connection, right? So that's the eye-opening results.
Is it fair to say, based on that, if we look at the United States, you spoke about density, you just spoke about, suburban living. Is it fair to say that we are basically stuck with the car in the United States because of, is that sort of what your analysis points to as we look toward the future?
Not necessarily. Okay. What I said is thinking about, like population density, that one may not play a role, but the distance to city center, they do play a role. So that means, even, the goal maybe is not about to increase population density, it's really to direct the future population growth into kind of the existing area, okay? Don't spread anymore, right? So in that case, we can reduce car ownership. And also transit play a role, okay? So for that case study, I just tell you one particular variable because I think that variable offers some new stuff, right? And then, but in that paper, we do see the distance to city center and then the transit play a role in terms of the car ownership. And also thinking about my suburban study, urban suburban study, that study, we say the population density and the land use mix, they don't play a role, but the job accessibility and transit, they did play a role. So that means, we do have some policy instrument, we can try to address this issue. But, it's going to take time, right? Because, it takes us 70 years to build the American landscape like this. And then we want to change it overnight. It's not possible. So that means we need to have this 1,000 cuts. Okay, abate. And then finally we can change, our behavior.
So this builds perfectly on a question that Seamus Joyce Johnson asked, which is, have you used any walkability and or transit service metrics to help predict car ownership? So I think you just referred a little bit to transit. Has walkability entered into your analysis?
For this particular study, sorry, no. Because I use this kind of the 5D network, so the density, diversity design, and then the distance to transit and distance to center, and also the job accessibility. So that means I do have the transit there, but I don't have the walkability there, right? And thinking about the walkability, they will play a role in, say, urban area. But I think in the suburban area, and then maybe that's, we could walk, but it's really for the recreation because there's no destination nearby, right? So that's going to be very difficult.
Right. Okay. So Ryan Westrom asked the question, he said, it feels like there could be variation in results based on the topography or geography of a place. In locations without natural boundaries like water, mountains, etc., there tends to be more redundancy of network. And I wonder if this affects the results.
That's a very good question. And so that's the reason I call for additional studies. Yeah, maybe, I published this paper. Maybe this just by coincidence, or maybe this is just type of an error, right? So that means we need other researchers to revisit this question. And then, so using the data from different areas, from the developed country, and from coastal cities, from mountain cities. So I want to see the generalizability of the results. And then at this stage, I don't feel comfortable I could answer this question because I need evidence as a scholar. I need to be conservative, right? So that's the reason I think that's a very good question. If you want to test that, and then yes, you are welcome to do so. And so in that case, that's going to enrich our knowledge. And then once we have adequate number of studies, we may do kind of a meta-analysis and trying to see, how can we generalize results, from region to region, from typology to typology.
Super. Taylor Reich asked a question. He said, it seems like Professor Cao has only applied machine learning to non-spatial or scalar variables. As powerful as this ML model development might be, I'm skeptical that only non-geospatial model will ever be enough to understand the key determinants of urban travel. So the core of his question is about using geospatial data sets versus, sort of just scalar variables. Do you have reflections on that?
Okay. Also, a very good point. First, I would say the machine learning is still kind of new for urban planners and even for the geographers, right? So, I think maybe after 10 or 20 years, we are going to have very good tools, right? So we will have scholars develop different tools, trying to incorporate the geo dimension of the data sets and then to produce maybe better results, right? But with that said, we do see some study in the literature, even for myself, I work with a scholar from China in trying to understand the connection between trying to understand the warehouse value, the rental price of the warehouse. And then in that model, we did include a spatial lag variable, right? So that means we consider how the neighboring warehouse will influence this warehouse. And actually we found out that spatial lag variable account for 24% of the predictive power. Yes, so it's really important. If we don't consider this one, we may have substantial amenity variable bias. So what I'm trying to say is
an example of that. Like, just give us an example of what type of spatial variable you might be talking about.
So that's we create a kind of a spatial lag, based on the distance of the warehouse. And then, so we have two warehouses using the inverse of the distance and then weighted of the price. So we have the rental price of the neighboring warehouse. We use that one as a variable to predict the warehouse rental price. And then we find that spatial lag, that variable, account for about a quarter of the predictive power. So it's pretty important. And then, of course, we know, we may have some other spatial, the weighted matrix, whatever, right? So we could use, and also some study, they include the longitudinal and then the latitude and altitudes in the model, and then trying to using the latitude and altitudes to show this kind of the geographical influence. There are many ways of doing it. So that means what I'm saying is the researchers are trying to, incorporate machine learning and then the geospatial data, but still, okay, research in progress. Maybe after 5 or 10 years, we will have stronger tools and then to address this question.
Excellent. Another question from Chi Liu, which is, do you think that large language models can help us build a highly transferable, generalizable model that understands the urban built environment and human interactions? Anyone interested in collaboration? This is specifically, I guess, getting into the domain of large language models. Your thoughts?
Yeah, that's something, the large language model, that's really not really my specialty, right? But I know, for example, one of my collaborator, he did is called Plan GPT. So he's trying to use the large language model and then integrate with planning. And also he worked with the planning agencies in Guangdong area. And then they have several contracts in trying to implement that. So that means, we do see the potential future. Okay, but this is still kind of the early exploration, right? Whether or not that's going to produce reasonable and then results, let's see, over the time, right? But anyway, I would say the model is still model. So who is going to explain the model? It's going to be the human beings. It's going to be the urban planners. So I don't think the model, okay, will tell us everything. It's rely on the human power, trying to interpret results and then to implement the results. And the model is model. And also don't forget, we have a lot of kind of the political issues associated with urban planning, right? So, that's kind of the ideal situation. But once we down to the earth, and then we find out, yes, this is a very good idea, but unfortunately, it's not doable because of certain issues associated with, the planning.
Excellent. And maybe Jinhua might have some comments as well about this concept of plan GPT, because I know that we've done some work in that area. Maybe one last question. David Maniscal, it's more of a comment, but there's a question embedded here. He said, I would think that city type would confound modeling as well if it isn't included as a variable of some kind. There are single core cities, multi-core cities, et cetera. Urban configuration matters. You talked to that, but do you feel like you've got this kind of rigorous typology of cities and that is recognized in the model work?
For my model, maybe not. Yeah, because we approach the same issue from different angle, right? So urban planners, the geographers, and then maybe the social scientists, they will approach the same issue from different perspective. And then I would encourage the interesting scholar to explore that, right? So they have a strong hypothesis, okay, a theory, to inform their decision making, okay? Because of this theory, we assume the city type will have certain kind of influence, and actually the connection between, say, the building environmental behavior will differ by city type, or maybe by typology, whatever, right? So that's their hypothesis. They need to test, right? So that's open the door for all the possible increase, right? So again, think about our traditional questions. We have using kind of 100,000 papers to answer the same question. You may want to use this machine learning to test it again. Whether or not this will produce kind of consistent results. Okay, if you find, for example, using the data from my city, okay, the result is different, and then using data from another city, we find the result also is different. And also these two machine learning studies have some level of similarity, then we may need to revisit our conventional understanding and revisit our theory, and then maybe rewrite our textbook.
Excellent. Okay, thank you. I'll turn it back to Jinhua.
Right. Thank you very much. Yeah. So John, to your question about the whole large language model, or now later large like image model, this foundation model as a whole, right? Indeed, Jason gave a very nice presentation about how you identify this nonlinear relationship that between certain variables on this. There are indeed many other areas we could talk about. For today, we won't have time. I just highlight one is on the to be able to digest non-numerical data like images, satellites, straight line images. Previously, we can have to first human engineer the feature manually, then you put it into the model. Now you can put the images, even texts, videos into that input directly, right? The second one is of course the generative AI, Gen AI application. We're moving from away from beyond just explanation, but to production and the design phase, right? That's an exciting area. Later we'll have another session to talk about that, right? So the time's up now. Thank you so much, Jason, for the presentation. That's a really nice conversation after as well. Everyone, please join me to thank Professor Jason for the presentation.
Thank you.
Okay, thank you very much for the opportunity, and also it's very nice to talk with the scholars in the world. And also in the chat box, I put the professor's name is Professor Wenjia Zhang from Tongji University, and then he tried this kind of plan GPT.
Fabulous.
That's great. Yeah.
Jinhua, maybe an announcement for next week's the Vision Day broadcast.
Oh, that's right. Yeah. So for the next week, October 25th, Friday, is the MIT Mobility Vision Day. It's an in-person event happening at the US DOT Volpe Center. But for the lunchtime, we do offer a special mobility forum session. So we will continue to use the Zoom link to broadcast the Mobility Vision Day, so people can at least get a kind of flavor of what we're talking about there. The theme during the lunchtime is the autonomous mobility, autonomous vehicle session there. So I will email everyone with some update on this, as well as the Zoom link to the Mobility Vision Day. Great, everybody.
We may not start at 12:03 exactly next week. It might be more like 12:05 or 12:07. So please be patient with us next week.
That's right. Yeah, thank you. So we should organize people in person to do that. Yeah, great. Jason, thank you so much again.